Hello again. We're working with Pythagorean identities here, and actually this is a pretty important topic, at least where I'm from, the Midwest. And basically what we're drilled to do is make sure that everybody passes their standardized test exam as best as possible, or does the best they can. And one question that always comes up in a math exam is the trig identity sine squared of theta plus cosine squared of theta equals 1. And some of the students who are taking the test have never seen this in their life. And I actually do take the time to explain this because they do see the Pythagorean theorem, so that you can relate that to trig. And it helps to an extent. But if you just memorize it, you don't really see what goes on because you're going to be given a different form of the Pythagorean theory, identity, and then whatever, you're not going to figure it out. So it's good to kind of show what's going on here. Now, here's the application they make, the step they make in a trig class. I call a squared x. I'm going to call it another variable. Now there's a reason why, though. I mean, it's not just out of thin air. I'm going to call b squared y squared, and I'm going to call c squared r squared. And basically what I'm going to do is I'm going to use it as a unit circle. Now, given, if you have any trig experience, the x value is equal to the cosine of theta. And the y value, cosine of an angle. And the y value is equal to the sine of an angle. And r is just the radius that we're working with. And on a regular unit circle, our radius is 1. We can always make it 2, 3, 4, 5, and I've already made that point in videos too. But I just like leaving it as 1 because I think that's the basic premise that students understand, and if you go from there you can use it as a building block. With that said, so x equals the cosine of theta, but if I'm going to substitute in cosine of theta for x, well, here's what I'm going to get. I'm going to get cosine, and actually it's cosine squared of theta. That's how it's written, but you can actually write cosine theta and then put a square after it. But this is the proper way to write it. Over sine squared of theta, and r is just 1. That's the radius, and 1 squared is just still 1. So this is the trig identity that deals with the Pythagorean theorem. And they say, you're going to get a question like this on the test, and students take the test and they don't see this exact same question. They think that teachers lied. It's not that they lied. It's that there's some kind of form of it. And there's basically 3 main forms of this identity, this being one of them. There's a couple more main ones. You can actually use more than that if you want to think about it, but here's what we're going to do. Let's say, hypothetically speaking, I wanted to divide by the cosine squared of theta on all 3 terms, because what I do on one term I have to do on all of them. Well, the cosine squared of theta over the cosine squared of theta is 1, plus the sine squared of theta plus the cosine squared of theta is the tangent squared of theta, because sine over cosine is tangent, so sine squared of theta over cosine squared of theta is tangent squared of theta, and 1 over the cosine is the secant, so 1 over the cosine squared of theta is the secant squared of theta. They say, you can also use this one, secant squared of theta equals 1 plus tangent of theta. It works when you do trig equations or trig identities, stuff like that. The other one that you can do, instead of dividing by the cosine squared of theta, is divide by the sine squared of theta. You could also divide by 1, but you're going to get the exact same thing. So that's kind of fruitless. So if I divide everything by the sine squared of theta, I get cosine squared of theta over sine squared of theta, which is cotangent squared of theta, plus sine squared of theta over sine squared of theta is 1. And 1 over the sine squared of theta is 1 over the, 1 over the sine of theta is the cosecant of theta. 1 over the sine squared of theta is the cosecant squared of theta. So you figure this out for the cosecant as well. If you want to figure it out for the tangent, just subtract 1. So tangent squared of theta equals secant squared of theta minus 1. Cotangent squared of theta is the same thing as cosecant squared of theta subtracted by 1. So you don't have to just solve for the secant and the cotangent. You can solve for the tangent and the cosecant. As well, I mean, you could just subtract the cosine squared of theta, and the sine squared of theta is 1 minus the cosine squared of theta. Or cosine squared of theta is 1 minus the sine squared of theta. Really tricky point for students. I hope that people who are watching this actually know the trig behind it. Otherwise, it's just a fruitless lesson. But if you do, then it's actually pretty useful, and it's pretty cool. If you you want to get that one extra problem right on your standardized test, it's kind of the way to go. Now that's the trig question. Well, something like that. With that said, have a good day for now. Goodbye.